and we're working on example 2. We want to solve for x, where 2x minus 3 over x plus 2, we have this rational expression is less than 1/3, and that's a rational number where x does not equal to -2. Okay, since we don't know which what x is, we don't know which direction the inequality will go when we multiply out the denominator. So therefore, we need to establish two cases. Case 1, when x plus 2 is positive, and we'll call that S1. In case 2, when x plus 2 is going to be negative. So since we don't know what x is, we don't know if that inequality sign is going to switch or not. So we have to establish x, the denominator, because that's what's being multiplied, and that's what could affect the inequality sign. We put the denominator positive, and for case 1, the denominator negative for case 2. Okay, so now we have here S1 is equal to, and all elements in set x such that, and then we have here 2x minus 3 over x plus 2 is less than 1/3, and x plus 2 is greater than 0. So we're just going to go ahead and do that first. All right, then we'll do cases. So this is case 1. And we'll write case 2 up there in a moment. So in that case, x is an element in set 1, if and only if we have 2x minus 3 over x plus 2 is less than 1/3, and x plus 2 is positive. Okay, so here we're going to go ahead and multiply out the denominator. X plus 2 times x plus 2. And since x plus 2 is positive, it's not going to switch the inequality sign. So that's going to be, cancel those two out, and we get 2x minus 3 is less than 1/3 times x plus 2, and x plus 2 is greater than 0. Okay, so now, to simplify things, we're going to multiply out this denominator 3. So we're going to multiply 3 to both sides and distribute, and get 3 times 2x is 6x, 3 minus 3 times 3 is 9. That's not going to change the inequality sign at all. And we get x plus is less than x plus 2, and x is plus 2 is greater than 0. Okay, so now we can combine like terms. So subtract x, and subtracting is not going to hurt the inequality sign any. Not going to change it. So that'd be 5x minus 9 is less than 2. and x plus 2 is greater than 0, and add 9 plus 9, and we get 11. So we get 5x is less than 11, and x plus 2 is greater than 0. So now we're going to divide by 5, and we get x less than 11 over 5. And here, we're going to solve. So here on the right side, we need to solve for x there too. So x plus 2 is greater than 0, we subtract 2 to both sides. And we get x is greater than a negative 2. So if we look at this on the inequality, on the number line, here's negative 2, here's 11 over 5. And we're saying that x is greater than negative 2. So it's going that way. And we're saying that x is less than negative, and is less than 11 over 5. So it's going to the left from negative 11 over 5. So that means the solution is in between negative 2 to 11 over 5. And so our solution for S1 is open, negative 2 to 11 over 5. And open at 11 over 5. Okay, so that's S1. So that's case 1. Now that's this case here, case 1. Now we're going to look at case 2, where x plus 2 is less than 0. So we go ahead and put here case 2. Is where x plus 2 is negative. And that's set 2. Okay, so from there, we're going to put in S2 equals to all elements in set x, such that 2x minus 3 over x plus 2 is less than 1/3, and x plus 2 is less than 0. Close that curly bracket. Okay, so from here we're saying x is an element in set 2 if and only if 2x minus 3 over x plus 2 is less than 1/3, and x plus 2 is less than 0. Okay, so we solve again. So basically the steps are almost identical. Okay, we're going to multiply out the denominator, x plus 2, x plus 2, that cancels out with that, and we get 2x minus 3 is less than 1/3, x plus 2, and x is plus 2 is less than 0. But because x plus 2 is less than 0, that is going to switch that inequality sign. So now, because the denominator is less than 0, that makes that inequality sign greater than 2x minus 3 is greater than 1/3 x plus 2. So now we're going to multiply out the 3, and we get, again, 3 times 2 is 6x, minus 3 times 3 is 9, greater than. 3's cancel out here, x plus 2, and x plus 2 is less than 0. Okay, so subtract x from both sides, we get 5x minus 9 greater than 2, and x plus 2 is less than 0. Add 9, we get 11. 5x is greater than 11, and x plus 2 is less than 0. Divide by 5, we get x is greater than 11 over 5. And here we're going to go ahead and solve for x, so we subtract 2, and x is less than a negative 2. So to finish this, x is an element in set S2 if and only if x is greater than 5 and x is less than negative 2. And we needed to do that. X is an element in S1 if and only if. So from there, we draw our number line, and we have negative 2. And we have 11 over 5. Here we're saying x is greater than 11 over 5. And here we're saying x is less than negative 2. Well, it can't be both. It can't be greater than 11 over 5 and less than negative 2. You can have them going in both directions. You can have them going in negative, or you can have them going both positive, one way or the other, or you can have them going to each other, but you can't have them go out opposing because there's no intersection. So in that case, S2 is an empty set. And since the solution is S1 union S2, well, S1 we said is a negative 2, comma 11 over 5, and S2 is an empty set. Well, we just drop the empty set and just write it as negative 2 to 5, 11 over 5 is our solution for S1, and it's just S1. And that's the example 2.